All right, we're continuing in our unit on exponentials and logarithms, and we met this thing a couple lessons ago called the natural log, ln, and we're going to work with that because we're going to see that those properties of logarithms that we dealt with before apply to natural logarithms as well. So if you remember the properties of logs, there were quite a few, and I'm going to show the same thing but using the natural logs. Okay, so remember how the properties of log work. The same thing works with ln's. So if you had the natural log of mn, well, that's the same thing as the natural log of m plus the natural log of n. And if you had the natural log of m over n, it's the same thing as the natural log of m minus the natural log of n. And if you had the natural log of m to the nth power, remember how that became the coefficient? It's the same type of thing. It's n times the natural log of m. So the properties of logarithms that we dealt with in the previous unit, and if any of this was confusing, go back to the previous video on properties of logs. Those same properties apply to natural logarithms. And with that, we should really be able to tackle these two questions quite without too much trouble. So I'm only giving you two examples because it just captures the same thing we've done before, just using natural logarithms, because as we remember, the natural log is simply log base e. So it's the same thing. Okay, so all the same stuff works. Okay, so jumping right into our first example, we have something, when at first you look at it, it's kind of confusing, but it should be okay once you are applying natural logarithms, okay, and the properties of logs. So here's our expression. We're going to evaluate this because this is actually a number that you can count on your hands. So we're going to apply those properties of logs. And the first property of logarithms that I think we should use is this property right here, that if you have the natural log of something raised to an exponent, the exponent becomes the new coefficient. And you may be thinking, well, Mr. Katz, that 1/2 is right there. Well, it doesn't matter. We're going to take that 8 and then just dump it right in the front anyway, because remember, all we're doing is multiplying. Okay, so basically we have 8 times 1/2 times the ln of e, right? And then we go on from there. And maybe we can, there's a few things we can do first. I would rather point out this. This needs to start jumping out at you. You see the ln of e? That has to start popping out at you, man. And you got to see that and have it pop, 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 pop. Did you know the natural log of e, or basically log base e of e, is equal to the number 1? Okay, so you can count on one hand what ln of e is. You can count on one finger what ln of e is. So ln of e is the number 1. We covered that a couple videos ago. So what are we looking at? We're looking at 8 times 1/2 times 1. That's what the ln of e is. And guess what 8 times 1/2 is? The whole shebang turns out to be 4. So in problem number 1, where I tell you to evaluate this logarithm, the whole thing turns out to be the number 4. So again, we're just demonstrating that all of the properties of logarithms that we had done before apply to natural logarithms. And that also puts it's the same thing for number 2 here. If we rewrite this whole expression as a single logarithm, we're going to start compacting it. Then what we can do is see how we can make this look nice and simple and sweet. So we look at number 2. We're going to compact this. We're going to write it as a single logarithm. We have the ln of a minus 2 ln of b, and then plus 1/3 ln of c. Okay, and then we can start using properties of logarithms. And again, the first thing that pops out at me, you don't have to do it in this order, but the first thing that pops out at me is that third property. Okay, so if we have this, basically a coefficient for a logarithm, that can be rewritten so it'll turn into the exponent. And so I'm going to apply that law right here. So I'm going to apply that property in the second term. So I'll have the natural logarithm of a minus, and now I'm going to call this the natural log of b squared. And then I'll do the same thing with ln of c. Okay, so plus the natural log of c to the 1/3 power, because that's that, basically the coefficient becomes the exponent. And now we can start using the other properties. Okay, so we know that if we are subtracting two logarithms with the same base, we can write it as one log as a quotient. That's the quotient property. So I can do that here, and I'll take it nice and slow. So we have the ln of a over b squared, and then plus the ln of c to the 1/3 power. And that's using that log. And then finally, our product properties. So we have the logarithms that when we add the two logarithms in the same base, that's the product property. So that's how that's going to work. And we can apply that right here. Okay, so we have the ln of a over b squared times c to the 1/3 power. See, we've condensed the whole thing right there. And we can rewrite this, make it look pretty or prettier. So the natural log of a times c to the 1/3 power over b squared. I will accept this, and you can even call c to the 1/3 power the cube root of c. So it really doesn't matter. Whichever you think is more aesthetically pleasing. Both of these I will accept, they're correct. Okay, so it doesn't matter. You can have this one, or you can have this one. It doesn't. Whichever you think looks better, that's all good. Okay, so that's basically it. This is a quick video, a quick lesson, because natural logs are logarithms base e. So everything that applies for logs applies to natural logs. And then in the last lesson, we'll worry about how we can use that in equations. So thanks for your time.